Hey guys, so we're going to be taking a look at the central nervous system and the peripheral nervous system and basically how everything comes together. And I've got the outline of the notes for you so you can kind of follow along with the PowerPoint with there. And we're just going to hit on some of those things as we go with this chapter. And so get some of the essence of it. This test is going to be mostly just kind of explain this part of the brain, what's the function of this. So it really does follow the outline of the notes that we have here. So I'm just going to follow along with the notes outline that you guys have, as well as the PowerPoint that I typically would use. Now, what we're seeing is a picture of the central nervous system as well as the peripheral nervous system. So if we take a look at this, we have the brain, we have the spinal cord, and then we have the nerves that come out of here. And so we're going to see throughout this that there is a difference between the central nervous system, what we call the CNS, and the peripheral nervous system, okay? Short version is the brain and spinal cord are part of the central nervous system. We find that it is responsible for controlling the peripheral nerves, but it also acts in another function, and that's so they work together. So we'll see throughout this entire unit, peripheral nervous system and central nervous system, that theme comes up. We'll hit that at the very end as well. Okay, so taking a look at this, just kind of a general overview, we see that we've got the spinal cord and some of these reflexes that go. So here's a picture of that spinal cord. We see some of the protective coverings over the outside, and we see a butterfly shape on the inside. And you see that we see a right and left half or hemisphere, as well as nerves that go out and in. So we see that the spinal cord is responsible for all those things. We'll get into that in just a moment, but I'm still on Roman numeral 1 on page 1. The spinal cord is part of both the peripheral and the central nervous system. So this part right here would be more of the CNS, and this would be over in the peripheral because that goes out to the arms and legs and so on. So jumping down to Roman numeral 2 there, the functions of the spinal cord is for sure going to be conduction. It is a power cord in every sense of the word in that way, but I think of it more of it like an HDMI cable in that it's also going to be responsible for not only sending messages one way, like to the brain, but also moving the other direction, coming from the brain out to the rest of the body. So it's a two-way street with this. And so today's terminology is more beneficial like an HDMI cable than anything else. So the spinal cord function, Roman numeral 1, letter B there, would be definitely responsible for locomotion. It flexes and extends things, but there's also the weird thing about the spinal cord is it acts as its own little mini brain in that if the stimulus one way or the other is strong enough, it'll jump this arc and cause its own little reaction, and let the brain know later on. We call that a reflex. So we'll talk about that a little bit later. It's an involuntary response. So what we're seeing in Roman numeral 3 is the composition of the spinal cord. We have the gray matter, that's this little butterfly shape that we see here, and we see the white matter. The white matter would be more the axons, kind of conduction. It's myelin sheath covered, so it protects it, kind of like an insulator that way. But looking more into the gray matter there, we have the dorsal version, uh, uh, portion of that, and we have the ventral portion of it. So the dorsal version right here, this is the part that's going to be responsible for the motor reflex or the motor message, okay? So this goes from the brain out to the body. Now, down in the bottom, this is going to be more the anterior portion or what we would call the ventral portion, and this is going to be the bottom portion here on the screen, and that's going to be sensory. So what's happening is the parts of the body are going to be sending the message in through the bottom part or the ventral part, the front part, and that message will go up to the brain, and the brain will respond and say how we want to move or adjust based off of that. So the downward message is going to be coming out of the posterior portion. That's important when we take a look at like neck injuries and so on. It's more common to have if you think about how the human body is set up, the ventral portion, we have the rib cage and everything up here. So we could definitely have the feeling and touch relationship there, but we might lose some of the motor reflex. So when you think about like a neck trauma or spinal injury of any kind, the first thing that they're going to be asking is, can you wiggle your finger? Can you move this? Wiggle your toes for me or whatever. What they're doing is they're assessing to see, is this portion, the dorsal portion, is that going to be damaged? Now that would make more sense because it's more exposed. Then if you could move it, then they're going to ask, okay, they're going to take something, maybe just something with a point to it, nothing really sharp or anything, but they're going to be saying, can you feel this? So they're assessing to see if the ventral portion has been damaged in that way. Okay, and then it is hemisphere wise, it would then be going out to the right and left portions of the body. Okay, so we see all of those things as we go through there. Now, we talk about some disorders of the central nervous system. One of the ones that you hear about, probably some a little bit older generation. Um, in fact, my sister, who's 4 years older than me, she has a little scar on her shoulder from the polio vaccine. I myself do not. I was born in 1973. You can call me old or whatever, that's fine. But I never received that vaccine because polio was not one of those types of things that we would worry about today in the United States. But we do see that in other countries where there's health issues and not as advanced health issues and treatments, polio is still an issue. Now, we always see these pictures of the United States of people in wheelchairs. In fact, we had a president who had polio. And the reason that's going on is because it's a disorder where we have fecally contaminated water. So think about that in terms of just modern technology. Nobody thinks about sewer treatment plants as modern technology, but the fact that we actually treat our water means that we will get rid of the virus that would be found in our water and contaminated water. Another thing we don't have is outhouses. Outhouses would just have a pit, and then some of the fecal matter might make its way into the water table, and therefore the virus would be transferred. But what happens there is, if I back up a screen, what would happen is this virus would attack the nerve pathway. So it would destroy the motor neurons. And so the people would lose the motion in their legs. They would lose the ability to be working those. Now, this is actually when that vaccine was really, I guess this is a good way to describe how panicked the United States was. In the 1962, when the polio vaccine was there, we think about it now and it's like, no big deal. We don't even really think about polio anymore. But look at the lines of people, and these would be like the entire community all lined up. In today's day and age, I think we can certainly think about diseases where people would be lined up for a vaccine like that. And polio was even stronger than this. The fear and dread of getting this virus was very real at that time. And so these would be an entire city wrapped around in blocks just waiting for that vaccine. Gives you an idea of how severe it was at that time. Now, another one you hear about is Lou Gehrig's disease, or ALS. ALS stands for amyotrophic lateral sclerosis. And so the reason they call it Lou Gehrig's disease is he was a New York Yankee, a professional athlete, and you could see even in the span of a season, his motor control and everything else was just devastated. And so what we find is that there was actually a very complex thing going on in the brain where it has to do with some hormones that are being released and so on. But essentially what happens with this is that the neurotransmitter, if you think about it in terms of the sliding filament theory, we talk about ACH, okay, the thing that irritates the membrane that allows muscles to contract. Well, what if you can't actually reabsorb that? Specifically, if we narrowed it down, acetylcholine esterase is not being able to be released. And the reason for that is some little pathways of dopamine and everything else. But really what's happening is the nerves would have all this constant firing message going on with acetylcholine, and they never be told to shut off. And so what happens is you get scarring of those nerves. And so what happens is these muscles would be in constant state of contraction. And so a person would be a living statue. They'd start with little hand tremors and things like that, and all of a sudden they'd be so strong and they would be incessant that the muscles would just lock and freeze. And so the real travesty behind all of this is a person is more than mentally awake during that time, just can't relax any of the muscles to actually make any kind of motion or vocalizations or anything. Now, another central nervous system disorder that you see on your list is shingles. Shingles is one of those things that it pops out in people that have typically a little bit older, 35 and older. We see it in high schoolers. We see it in college students. Or we find it in people that are immunocompromised and almost always following along a nerve pathway. The reason for that is because of the chickenpox virus. So what happens with the chickenpox virus is it's one of those weird viruses that's really tricky. As soon as the human body, the white blood cells start to attack the white blood cells or attack the virus, that virus will actually retreat into the central nervous system behind the meninges layer, so your white blood cells can't actually attack it at all or address it. And so at different times when a person is just stressed or the immune system is worn down or whatever, we find that the virus will actually leave and then all of a sudden manifest in shingles. Extremely painful. The sores are not itchy like a chickenpox virus would be, but it is the chickenpox virus, but it's just manifested in a different way. Extremely sore, And it's one of those things that takes a long time to go away. Now, I talked to a couple doctors about this, kind of picked their brain about it, and they said that if you had the chickenpox vaccine as a child, you are conceivably going to be protected against the chickenpox. It also then infers that you will never get shingles. And so, based on what they said with that, it kind of makes sense. If you've already built up the antibodies, the virus itself can't enter and take root, and so it would never have a chance to hide and all those other things. So maybe we got 2 for 1 on that one with the shingles. And another one not to overlook is spinal cord trauma with whiplash. And it has to do with a little bit of physics of how things go. But if you're moving forward and you slam into something very quickly, and what happens is you get that stressor on there. And so the trauma on the spinal cord itself tends to block that pathway. Now, here's the image that a doctor would see. And the question is this person paralyzed? Is it something that they're going to recover from, and so on? Now, the image, it looks like it's torn. It looks like it's going to be, and we don't have the technology currently for the spinal cord to actually repair itself. Now, stem cell, they've done stem cell research. They've done a ton of progression with that, and they've done the animal testing with it where they were able to actually regenerate some spinal cord. So maybe that's it. Now, our notes will have that 55% of all car accidents involve spinal cord trauma of some kind, if not whiplash. I'm going to actually go on a limb and say that that's probably closer to 90% in today's day and age. The reason? Fewer people are actually aware of what's going on when they get in a car accident. They're looking down, they're texting, they're doing all those things. Distracted driving is what we'll just call it, because I've even seen people shaving or reading the newspaper while driving, as odd as that sounds. But it's the same concept where if you don't even see something coming, first of all, you don't slow down, and second of all, you don't prepare your body for an oncoming impact. So we get some issues with that. So I would say that the 55% of all car accidents, that's actually a really low and dated number. I would say it's probably closer to 80 or 90% myself. And the question is that broken, or is that going to just given time repair itself? We just don't know from those things. Now, we take a look at the rest of the notes and we talk about axons and dendrites. We've seen that before, and we'll talk about that later. But the next thing to move on to is reflexes. Now, remember I said within the spinal cord itself, we have these bottom messages that are going to be motor, and we have these ones that are here that are sensory. But what if the stimulus is actually too strong enough or sudden enough that the muscle, or the spinal cord, I should say, is going to make a decision on its own? So the stimulus is strong enough. Think about it just in terms of electricity. If this electrical impulse is strong enough, maybe it's going to jump this arc and then cause a reaction. So we're going to take a look at the types of reflexes. The first one is called myotatic, otherwise known as a stretch reflex. We've all seen this one done. You go into the doctor's office, you have your leg hanging over the edge of your bench or whatever, and they tap onto your patellar tendon with a percussion hammer. Now what happens is you're supposed to be nice and loose and relaxed during this time, and so when they tap on that, it actually stretches this, which pulls the muscle this way. What they're doing is they're seeing how good are your reflexes, how responsive is it? Is it the right amount? Is it the right amount of time? Is it too strong? Is it too sudden? Is it too delayed? They're looking at the health of your nervous system as a whole and doing that. Now, the reason why your leg would kick out when you get tap onto those special places is because you're pulling on the tendon, you're pulling on a loose muscle. It's actually loose and it's lengthening. And so what the stimulus is this loose muscle is being pulled, so we better, to prevent tearing, we better contract in the opposite direction. So that's a stretch or myotatic reflex. Now, we take a look at another type. It's called a flexor reflex. Okay, this one has to do more with a pain reflex or maybe a temperature or something like that. So you think about a very sharp, a different type of nerve ending there. It's not the muscle itself. It's actually sensors within the skin. And what if you actually touch something hot or you touch something sharp or something like that? That specific type of nerve is going to be responding. And so what's going to happen is we hit that type of nerve, sends the message into the spinal cord. The spinal cord determines that that's going to be a strong enough stimulus that it causes the muscle to flex on its own. Remember, this doesn't have anything to do with the tendon. It has to do with the type of nerve being a pain receptor of some kind. And so what's going to happen is the muscle is stimulated to pull away in the opposite direction of that impulse. Okay, so it's a different type. It's called a flexor reflex. Now, a crossed extensor reflex. This is kind of an odd picture. Most people think of the crossed extensor reflex as this one. Okay, when you're tightrope walking, you're falling one direction and then you get all awkward because you're throwing your arm out in the other. I like to throw this one out there as another option because they deal with this in kind of self-defense training. They deal with this in martial arts and everything else. And I'm not a martial artist, so don't get that impression. But if you think about it, if somebody is trying to grab you, if you pull down on their arm, okay, if you push it down, what's going to happen is that their opposite arm is going to go flying up. And if you know that, if you train with that, you can actually monopolize on that and cause that person to tip over even more. So again, if they're pulling out, you can push down on their arm. You know that this back shoulder is going to go up, and so you can get underneath there and push them over. Just take advantage of that as you go. So it's the same kind of concept here. When you see a tightrope walker and they're starting to get their center of gravity off here, they're going to throw the arm or leg out in the opposite direction to try to reestablish that. Here's a little fun tip if you're taking a look at circus performers and so on, the high wire acts, the acrobats and all that, you can always tell the really bad ones or the really kind of lower grade ones because they have this big long pole. The longer the pole that they have while walking on a high wire, it's actually easier to walk across a high wire with a long balancing pole like that because it's easier to establish your center of gravity. The really good ones are the ones that work without any kind of balancing pole or at least a very short one because it's really hard to get your center of gravity going with that again. Okay, now the last one is kind of a lesser known one. It's called the Golgi tendon reflex. So think about these really old pictures, old kung fu movies. I always love those because they're so cheesy and really bad voiceovers and everything else. But there's always this really old master that goes out and he's got to save the day. And so there's this bad guy that comes out and he's doing all his flippies and all those other fun things. And so this really old guy who can barely even move, all he has to do is he has to grab onto the guy as he's trying to do all these weird things. And he just goes and touches a couple spots and the guy just goes down or maybe even dies. And so what's actually happening, that's actually based on a true thing, is a Golgi tendon reflex. So let's think about this in terms of these 3 steps. This one took me a little bit of looking for. So yeah, it's just kind of one of those weird ones. So a person is going and attacking, and so their tricep is actually flexing at this point, trying to elongate that arm. And so what the other person does is they trap that appendage or whatever, so the muscle is still flexing. And so the person then that's defending against it, that person would grab onto a muscle that is already flexed and add extra pressure to that flexing muscle. Now, this is opposite of the stretch reflex. So the muscle is flexing, and so we put extra pressure on there. What's the signal to the muscle? The signal is, oh, we're going to be tearing because I'm flexing so much and it's being extra pressure on there. And so the result is the muscle actually relaxes. In fact, I was reading up on this because I was kind of intrigued by it. And so they were talking about this, and a person actually has about 30 seconds or more where their entire body just goes limp. And if you get the right spots on the Golgi tendon, I was reading more on this. They were saying that if you get the right spots on there, that you could actually stop a person's heart based on that, because depending on the nerve pathways and so on. So if you think about it in the terms of the Vulcan death grip or anything like that, it's actually based on a real thing. If the muscle is flexing, you add extra pressure to that, then all of a sudden that muscle will be given the stimulus, or the stimulus would be that the muscle would tear because it's flexing so much, and so it automatically relax. That's another type of reflex. Okay, now I'm flipping the page and taking a look at a couple other things here. And it's just taking a look at the central nervous system and the coverings there. We've seen this before when we dissected the brain, but we do have these 3 layers called the meninges. And so the meninges consists of the outer layer, the really tough one, the dura mater. We have the arachnoid mater, which is the space that has kind of the filament layer, and everything else has that, and then directly underneath that is the pia mater, referring to the little mother, if you will. And that's the layer that's going to have the blood vessels and so on. And so what can happen is we have 3 different layers to protect the central nervous system, the brain and spinal cord, and sometimes you can get an infection in there. Okay, and so we can get what's called meningitis. Now, meningitis is a bacterial or a viral inflammation on the inside, and the problem with that is kind of twofold. First of all, if it's bacterial, it's going to multiply within 24 hours, it's going to multiply to over 1 million bacteria just starting from one single cell. Or if it's viral, but then the other problem is that the immune system itself can't go through this barrier. And so all of a sudden we see this buildup in there. And so we have problems where your immune system can't even address it. So you have a very serious type of situation. Now, I should mention in there that how you know you have possibly meningitis is going to be the only way is to really take a sample of the cerebral spinal fluid, but you have the symptoms where you have a really high fever, you have a stiff neck, drowsiness, and so on. And so that would lead into a coma, and the person would never wake up from that. So kind of a gross picture, I understand that, but it's understanding what meningitis is all about. And a lot of people, well, you can't even get onto a college campus for you seniors, that you're gonna have to have at least the vaccination for the viral version of this. Okay, now the next section that we're going to be taking a look at is going to be dealing with components of the brain and taking a look at brain stem and all those other things. So that's going to be in part 2 of this video series.